Okay. And you will need your graphing calculator towards the end. So I'm going to teach this lesson in 2 days. So this is day 1. And we are referring to lines in the plane. That will be the coordinate grid plane. So just a reminder of your slope formula. So slope is known as the change in y over the change in x, or the difference between your y's over the difference in your x's. It's denoted as m, and the actual formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I assume that you know that. You won't be good enough. So, example 1, you will be expected to find the slope. Given. So on A, I want you to find the slope using the point negative 1, 2, and 4, negative 2. Now, theoretically, you could plot the points and use Pythagorean's theorem to find the slope of the line, but that would take effort, especially if the points are really good. So go ahead and do the work again. I would suggest that you are using a template, especially because the slope formula has negatives in it, and you have been given negative numbers within the units. So it would be beneficial if you started off with the template first and then plug in your points. And this one does make a difference. As far as if you choose y sub 2 to come first, if I choose to put a negative 2 here, and then the 2 follows it, when you're down in the denominator here, that x sub 2 must come first. So the points to each ordered pair must be vertical to each other within the slope formula. But I could switch these two. So I could have had the 2 and the negative 1 first, and the negative 2 and the 4 second. We would all get the same answer. But what you can't do is have the actual points itself, so like 4, negative 2. 4, negative 2 could not be diagonal to itself. And that's what so just be careful. So for this particular one, we end up getting add the opposite, we get a negative 4 over 5. So the second one's all 1, 1, and 3, 4. Find the slope. Slope is never written as a decimal. I've seen that in some textbooks, so it's quite uncomfortable. You try plotting a decimal in the coordinate grid as a slope. It doesn't work very well. And slope should never be written as a mixed number. It should always be written as a fully reduced power function. So what do you get? Positive or negative? It's positive. 3 halves, right? All right, so then we're going to actually write the equations of lines. We're going to have to use the knowledge of finding slope given 2 points. So the point slope form, this is my favorite form of a line. It's the most useful form for writing equations of lines. So point slope form is y minus y sub 1 equals m times x minus x sub 1. All we need for point slope form is a point and slope. So the only thing that you're going to sub into this equation would be the following. You're going to sub in y sub 1, x sub 1, and slope. The plane x and y stay as is. They never get substituted. So, some teachers will only teach you to use this if you have a point and a slope. I'll use this for 2 points, a point and a slope. The only time I won't use this is if I have a slope and y-intercept. The only time I won't use it. Every other time I'll use it always. So for example 2, you are to write the equation given the following. So I'm going to give you -3, -4, and a slope of 2. So the formula that I just gave you above, the point that they gave you is your x sub 1, y sub 1, and your slope is your m. So we're just going to plug into that formula. Y minus something equals something times x minus something. My y sub 1 is -4. My x sub 1 is -3. And my slope of 2 goes in front of the parentheses. Now you have to pay attention to how they want the answer written. If they don't mention how they want the answer written, you would have to clean this up for point slope form. So if they wanted it in point and slope form, you would take care of any double negatives and any zeros. And if there's a 1 or a 0 here for slope, you'd take care of that. But other than that, you pretty much leave it alone. So we're going to take our double negatives here and write y plus 4 equals 2 times x plus 3. This right here is your point slope form. If the question wanted you to have the final answer in slope intercept form, what does that mean to you? Yeah, you distribute the 2, solve for y, you have it in y equals mx plus b form. So we're going to distribute the 2 first. So we get y plus 4 equals 2x plus 6. Subtract your 4, you would get y equals 2x plus 2. So this right here would be slope intercept form. The only other form that they might have you do is general form, or you've heard it called standard form before. I find that the most useless one. You won't ever see me asking you for it, but your textbook might. So math, Excel, and I'll go over that in a minute. Let's do one more point slope form one where it's a little bit more difficult. So example 3. Write the equation of the line given. I guess I should say the line. So you're given -1, 0, and 5, 4. So I will never use slope intercept form y equals mx plus b unless I have slope and a y-intercept. If I don't have slope, or either one of these, the y-intercept. Sometimes when 0 is in a point, it could be the y-intercept. If you plot that point, is it on the y-axis or the x-axis? -1, 0, x or y-axis. It's on the x-axis. So I don't have my y-intercept either. So I'm definitely using point slope. But for point slope, I need 1 point and a slope, and I have 2 points. So you're going to use the 2 points to find your slope. So step 1, find slope. formula to find slope. So I'm going to plug in my values for my y. So I've got 4 minus 0. Since I chose to have 4 come first, my x's, I must have 5 come first in the denominator, minus negative 1. And my slope ends up being 4 divided by 5 plus a positive 1, 6, and that can be reduced to 2/3. So there's my slope. Then the second step is you need to choose a point. Choose one of the points. I would actually choose this one because it has a 0 in it. It tends to be easier, although it does have a negative, so that's a drawback. You could choose this point. If I'm asking you to write the equation in point-slope form, if you choose this point versus this point, those forms are going to look visually different. If you solve each of those equations for y, you would all have the same line though, but in point-slope form, they're going to look different. So typically, I will tell you what point to choose if I want it in point-slope form when you're given 2 points, because otherwise I'd have 2 different answers. I'm going to choose, for demonstration purposes, the point that has 0 in it. I want you to see what you do in point-slope form. So, we're going to do y minus something equals something times x minus something. So I've chosen this point, so 0 is going in for my y sub 1, and then negative 1 is going in for my x sub 1, and we found our slope to be 2/3. So in point slope, you have to take care of any double negatives, zeros, and any ones that might be, or zeros that might be in the slope. So y minus 0 is y. I do not distribute the 2/3 when I'm writing it into point slope, but I do take care of the double negatives.
Do you want us to do this? Like this is point slope form, this is slope intercept form?
Yeah, for your note purposes, you need to write that down because it looks like slope intercept almost, doesn't it? But this is actually your point slope form. If we wanted it in slope intercept form, then you would just distribute that 2/3. And then this would be considered slope intercept form. So questions on that? Hopefully that's ringing a bell. Some of you may have had teachers in the past that don't ever use point slope. They always use y equals mx plus b. When writing an equation, point slope form is the most useful form. It's the form that gives fewer errors. Whereas y equals mx plus b, I get a lot of errors in that. So let's look at slope intercept form, just for children's sake. In case you don't know, I would imagine that you can do. Slope intercept form is exactly what it implies. You have slope and a y-intercept. So y equals mx plus b, where this is your slope and this is your y-intercept. Again, you'll never see me demonstrate using this to write an equation of a line unless I am directly substituting in m, slope for m, and if I've been given the y-intercept, I'll directly substitute in there and it has no work. Otherwise, I'm always going to be using point slope, 100% of the time. All right, so you write the equation of the following line. You can use whatever method you prefer, because some of you are going to be gung-ho on using this method. But we'll see. All right, so example 4. Write the equation of the line given. Negative 1/6 and slope of 3. answer, put your answer both in point slope form and also in slope intercept form and label which is which. And then when you get the answer, share it with everyone. Share it. Talk amongst yourselves. Show them what you got.
Don't you have the same oh, why do you use it? There we go, really take that. No, I
All right, so we ready? I hear some of you fix some errors. That's good. There's your point slope form. Right, so the only thing you had to take care of in point slope form were the double negatives here. And then in slope intercept form you had to distribute and then add 6 to both sides. You good with that? Now you could have used slope intercept form from the beginning, it's just different. And as I said, I have more students making errors with that than point slope form. Okay, the last thing we're going to do is using your calculator to graph with. I have my little school bus calculator. So let's start with graphing. Let's go back and graph. Example 2. So you should know how to do this because we practiced it last week. So a couple things you could do. If you have point slope form, you could just on this one subtract 4 from over here and you could write 2 times x plus 3 minus 4. I'm going to show that it gives you the same thing as this one. So I could just do 2 parentheses x plus 3 in the y equals, and then subtract 4. So you have to have it solved for y. So I could solve this for y without doing much work in my calculator and put that in there. If I hit graph, it should cross the y-axis at 2 and have a positive slope of 2, and sure enough, it does cross at 2, and it appears to have a positive slope. So if I change that in y equals back to the slope intercept form of 2x plus 2, I should have exactly the same graph. And do I? It's exactly the same. And I could double prove it if I put it down here as well. So 2 parentheses x plus 3 and parentheses minus 4. Same one, right? Okay, so I want you to graph example 3 using this one right here. I want to see what you put into the calculator. So you're going to go to your y equals. Okay, go into your y equals and then put that in there using parentheses. And then share your display with those around you. If somebody doesn't have their calculator, you need to get with somebody who does and see what they're doing. Because this is part of what you're going to have to do on your homework tonight.
my partner is right this way.
You're what?
My partner is right.
Are you sure?
Yeah.
Good, my emergency bow tie.
Your emergency bow tie in case you need one. All right, here's what your graph should look like. Now, if your viewing window is not a standard viewing window, it can change how your graph looks. So make sure if your graph doesn't look like mine, go to Zoom and hit 6 for standard. And what that will do is it will change your window. So if you go here to window, it will change your viewing window to what you need it to be. Go ahead and put the following into y equals. So clear this out. If you were to put in, negative 3x plus 20. Let's say that that was your equation, you had your graph. Hit graph, what do you see? Where's the y-intercept on that one? You can't see the whole line, right? So you can change your viewing window to see that whole line. Since you know that it has to cross the y-axis at 20, go into window, and you have your settings for your minimum and maximum for x, your minimum and maximum for y. We really want to change the y here so that we can capture that part of the graph. So if I take my arrow keys and scroll down, my y minimum is okay, it's my y maximum. If I put it on 20, would that be okay? No, I want it higher than 20, don't I, so I can actually see where it crosses? And so I'm probably going to put it at 25. And you can change your scale if you wanted to, or you can leave it the same. You can kind of play with it and see what it looks like. When you change your scale, your graph is going to look different than somebody else's. But now I can actually see where that graph goes. The slope of that line appears to change. It appears to get a little shallower because they had to adjust the scale here. The y scale is different from the x scale, as you can see, because they had to adjust distance-wise to get all of those in there. If you go back to hit zoom 6, it will bring it back to the standard viewing window, and you can see that the line now appears steeper. So you can adjust your window, and you might have to, depending upon what you have. So the last question that we're going to do today is example. Am I on 5? Oh, before I do the example, let me give you your few other things. General form. So general form of a line I find fairly useless. The only time it's really useful is if you're doing systems of equations, in my opinion. You have a capital A x plus a capital B y plus a capital C equals 0. Now, in the past, because this is a different publisher, in the past, in your Glencoe Algebra 1 book and your 3-4 book that you learned, standard form would have been ax plus by equals c, and c would have been over here. And they insisted that a, b, and c not be fractions, which is still true. So you might want to write that over here. A, b, and c cannot equal fractions or decimals. And then a must be greater than 0, must be positive. It's typically what you'll see for general form. It's just a method of manipulation, to be perfectly honest. All right, then your equation for a vertical line, we use a lot of vertical lines in pre-calc. Vertical lines go through what axis? This is a vertical line. Vertical lines go through what axis? The x-axis. So it's always x equals some number. And so you might want to put a little hint here. Remember, this is what a vertical line looks like. It always goes to the x-axis. That's why it's x equals some number. And horizontal line. There's a lot of horizontal lines in pre-calc as well. Horizontal lines are this way. They go through what axis? The y-axis. So it's always y equals a number. Visually, a horizontal line would look like that. So those you also might have to know, so make sure that if you're asked to put a line in general form, that you know how to do that. Final example for today, example, I think it's 5, right? Okay. Yes, is that correct? All right, good. Alright, so example 5. Graph the following on your calculator. So we've got 2x plus 3y, and you're going to draw a sketch of it, equals 6. Is that a form that we can put in the calculator? No, of course not. So you've got to solve the equation for y. So we're going to subtract 2x from both sides. You will typically see me putting into slope-intercept form just because years of doing this, I'm not going to change my ways. If you wrote 6 minus 2x, it's not going to affect a thing. And if I'm not asking you to write the equation in slope-intercept form, then it would have been okay to write it that way. Then if I divide the left side by 3, I must divide the entire right side by 3, which means that each of these get divided by 3 as well. Which means your final form is negative 2/3 x plus 2. So this is what I'm going to put in my calculator. So this gets put into y equals on the calculator. So on your calculator, glare off of there. I'm going to go into y equals, there we go. And remember if you use parentheses for that fraction, and then x plus 2. You should already know what direction the line should be tilted. It should be tilted to the left. And let's go ahead and sketch it. I'm going to assume that if you don't label your axes, that it's going by ones. If you change the scale on your axes, you must label them. But it shouldn't have created an error, so I'm not sure what you did. But you had menu buttons down there. Alright, so does everybody have that? So where does it cross the y-axis? At 2. And it has a negative slope. And so it should cross the x-axis at, the 0 is at 3. If you go down 2 and to the right 3, it does hit the x-axis. And so in my world, when we're sketching it, you're intercepting your x and y axis for a line are what we're looking for. So that's it. Any questions? Tomorrow we're going to look at parallel and perpendicular lines and word problems dealing with lines and slope and that kind of thing.